The next pattern is a pyramid. So let us analyze the pattern. So the first step would be to divide the pyramid in terms of rows and columns and label them. So we have already done that. Rows start from 0 and goes all the way up to 2, and columns start from 0 and goes all the way up to 4. A very important observation, as you can see, there are only odd number of stars in each row. So there's going to be one more pyramid pattern which is going to contain odd and even number of stars in consecutive rows. For example, in the first row there'll be 1 star, in the second row there'll be 2 stars, and third row there'll be 3 stars. That is pretty simple to design, but this is going to be a bit complicated with odd number of stars in each rows. And there are also empty cells on the left side, so we need to take care of them as well. So here let us assume the input to be n, which is equal to 3 in this case. Now we need to identify a condition to print the spaces exclusively. You can ignore all the spaces which are present on the right side. And as I've already told, the number of stars in each row are always odd. This is an important observation that you have to make. Now, cell by cell, address description. R0, C0, we are printing a space. R0, C1, we are printing a space. R0, C2, we are printing a star, and so on. So we write this for all the locations. Here, there is no relation between rows and columns. Since there is no direct relationship between rows and columns, so we need to find out another logic to print this particular pattern. But there is a relationship between number of spaces and rows. So this is the second important observation that we have made here. As you can see here, in row 0, there are 2 spaces. In row 1, there is only 1 space. In row 2, there is no space. Okay, so let us see how best we can describe the logic for this. When r is equal to 0, number of spaces are 2. We have made a note of this here. When r is equal to 1, the number of spaces 1. When r is equal to 2, the number of spaces here are 0. Now we have to convert these numbers in terms of n which is our input. So 2 can be written as n minus 1. N is 3 in this particular case because there are 3 rows. So 2 can be written as n minus 1. Next, 1 can be written as n minus 1 minus 1. 0 can be written as n minus 1 minus 2. So for any given r, number of spaces would be n minus 1 minus r. As you can see, this is r. When r is 1, here 1 can be replaced by r. R is 2, here 2 can be replaced by r. So the general formula to print spaces would be n minus 1 minus r. So the column loop condition, that is the innermost loops condition, should be C is less than n minus 1 minus r. So why it is less than here? Whenever we are using n directly, we should always use less than, because we are starting the loop condition from 0. If we start the loop condition from 1, this will be less than or equal to. This is an important thing to remember. So after printing the spaces, we should print stars. So this particular logic is for printing the spaces only. Now we have to design a logic to print stars. Let us see what the logic would be. Again, this would be the same process. When r is 0, there is 1 star. When r is 1, there are 3 stars. When r is 2, there are 5 stars. So till here, it is pretty simple. Now we got to know whenever r is 0, stars are 1, r is 1, stars are 3, and r is 2, stars are 5. The next important step would be to translate these numbers in terms of r. So how can we express 1 in terms of r? How can we express 3 in terms of r? So this is the formula. So we have to arrive at this particular formula just by looking at the numbers. So when r is 1, how do you get 3 from 1? You can multiply 1 by probably 2 times and then add a 1, or you can experiment any other formulas. But here for us this actually worked. How do you get 5 from 2? You can multiply 2 into 2 and you can add 1. So that is what we are doing here. So it is 2 into r plus 1. So r is 1 here. So 2 into 1 is equal to 2. 2 plus 1 is 3. Then we get this straight formula here. So we can generalize this as 2r plus 1. So whenever r is n, the number of stars to be printed are 2r plus 1. Now there are two ways to print the stars. Either you can use a while loop or you can use a for loop. So in this particular uh, pattern, let us use while loop. So we'll declare another variable called as stars and we'll assign it to 0. And this will be the condition to print stars. While stars not equal to 2 into r plus 1, you have to print star. Then you increment the stars. So when it comes here, it's going to check the condition. It's going to check that when stars are not equal to 2r plus 1, print a star, increment, print a star, increment. Then when this condition is false, it is going to assign stars with 0 again, and then it is going to move to the next row. So this would be the entire logic to print the pyramid. So we are assigning stars to 0 or 0 to the variable called as stars, and this is going to be the first outermost row loop, which is going to run from 0 all the way up to n, and this is the innermost loop, that is the column loop. So whenever c is less than n minus 1 minus r, we are going to print a space. So this entire loop is dedicated to print only spaces. Next, we move on to a while loop. In while loop, we are going to check this condition. When stars not equal to 2r plus 1, we are printing a star, then increment. Then after coming outside the while loop, we are going to reinitialize stars with 0. Then we'll move on to the next row. Again, increment r, then print spaces. Again, stars would be equal to 0 here. Again, it will print as many stars as this particular condition satisfies. Again, reinitialize stars with 0, move on to the next row. So this is how you're going to print a pyramid.